This video is the second review on exponential and logarithmic functions, and let's say someone is hanging out in the math lab, which guys, by the way, you can go and get help. But if you, let's say someone was trying to demonstrate to a student that the log of m divided by n is equivalent to the log of m minus the log of n. Now, explain the contradiction. If they put this in their calculator, the log of 13 over 7, and then took the log of 13 minus the log of 7, they get different answers. Why? Well, guys, this is something I see students do a lot. That's the reason I wanted to take about 30 seconds or so to show you something. When you do the log of 13 divided by 7, that has to be in parentheses. Because if you do the log of 13 over 7, it sees it as the log of 13 divided by 7. However, if you use the parentheses, it sees it as the log of 13 divided by 7. So let's see the difference here. So if I put in just the log of 13 and divide that by 7, you'll see that I get the 0.1591 like they got when they did it incorrectly. However, what we need is the log of 13 divided by 7, which gives you 0.2688, which gives you the correct answer. Now, you think I've ever seen that before? Obviously, I do. Obviously, I have, or I wouldn't have wasted your time showing you that example. So, anyway, let's see. Let's kind of readjust some things here. Okay. The reason that we study exponential functions and logarithmic functions is really because of these two formulas. Now, if we always had the n and the t, if we had the number of compounding periods and the time, then we wouldn't need logarithms because we would never have an exponent in a variable in the exponent that we need to solve for. A equal P times ERT, same thing. If we always knew the rate and the time, we would have just an exponential function. But there are times where we need to solve for the number of years or the number of compounding periods or the rate or the time over here, which motivates the need for logarithmic functions. So let's just run through a few of these. And guys, remember when we're talking about compounding, n times per year. If we're talking about continuous compounding, then we use, I call this the shampoo formula, P-E-R-T. I don't know if you guys have ever seen PERT, the shampoo. Okay, sorry. A little bit of a tangent there. All right, number 2, find the value of an investment of $10,000 in 12 years that earns an annual rate of 3.95% compounded continuously. So guys, what we got to do is we got to use this formula right here. So find the value of the investment. So we have A equal 10,000 times this number E. We have 12 years, so that's going to be our T. We have a rate of 3.95%. So guys, we always have to convert that to a decimal, 0.0395 times 12. Now, we have to pay a little bit of attention when we put this in our calculator. Well, we don't. We have to pay a lot of attention. So we're going to have 10,000. I'll tell you what, let me get this up. So we're going to have 10,000 times that number E raised to the 0.0395 times 12. Now, guys, if you've got a calculator that doesn't come in and automatically put that parentheses, you must put the parentheses there for the same logic of this example up here. But, most of the new operating systems will put the parentheses there. Or I've even seen some, and I'll tell you what I'll do. I'll get out of here and show you how some of the others do it as well. Some of the others just pop it up to the exponents. So anyway, let's go enter, and we can see that we get 16,064. 0.07. So you'd make about 60, pretty close to $6,100 interest. Now, guys, let me get out of this, and I want to show you how this would happen on a different type of calculator. If you put in 10,000 and went to E, sometimes it'll just take it up to the exponent. So what you've got to do here, is you've got to put everything you need up there. We did say 12 years, right? Yeah. And then if you need to get out of the exponent, you hit the right arrow and it would bring it out. So if you needed to multiply by something else or subtract, maybe you needed to subtract 2 or, whatever it may be, you can get out of it by just hitting your right arrow. But we don't need to do that here. And we can see we get the same answer. All right, gang. That was easy. It's going to get harder, as you would expect. All right, find the value of an investment of $2,500 in 15 years. It earns an annual rate of 3% compounded quarterly. Well, guys, here's the formula that we need to use, and we just need to put the corresponding numbers in the corresponding part. We want to find the ending balance. We're investing $2,500. 1 plus a rate of 7%. Don't you ever use that 7. Use 0.07. Compounded quarterly. Says we have a 4 there. And we want it over 4 years, so that'll be 4 times 15. Now, a lot of students have problems putting all of that into their calculator in one step. If that's you, I'm going to show you 2 different ways. I don't have a problem doing that. I can just go 2,500 times 1 plus. I know that has to be in parentheses, the 0.07, divided by 4. You're going to find a constant theme in this class. Any time you have a fraction, you need to put that, the fraction in parentheses. And I can raise this to, now a lot of students will go 4 times 15, which is pretty silly because it just told you. You have to let the calculator know that every bit of that goes in the exponent. If you raised it just to the 4 times the 15 without the parentheses, it would raise that value to the 4th power. It would then multiply by 15. You don't want that. You want it raised to the 4 times 15 power. So guys, you're going to end up with 7079. 0.54. Now, I've had students tell me before, yeah, that's fine. I just have a hard time keeping all the parentheses and everything straight. Well, guys, do it little by little. Let's come in and do the fraction first. No parentheses needed. We know that we got to add 1 to that. Please excuse my dear Aunt Sally says that I have to do the exponents next. And then I got to multiply by my 2,500. Same answer. Which one do you need? Put it all in, wham bam, thank you, ma'am, you're done, or do it step by step? I don't know. I don't know. That's you better than me. But there are going to be students that this is going to work better, and there will be students that will be able to do that. So different strokes for different folks, guys. Number 4, a person wishes to have $1,500 in cash for a new car 5 years from now. How much should be placed in an account if the account pays 6.75 compounded weekly? Well, gang, same thing, really, sorta. Just given different information. Now, the thing that varies here is we want to end up with 15,000. This is what we end up with. So in essence, we don't know our P. We need to calculate what we need to invest right now to end up with that 15,000. Well, our rate is 0.0675. Compounded weekly, so we should all know there's 52 weeks in a year. 52 goes there too. And we need 5 years. A lot of stuff going on. I know, though, that I need to divide this side over here and this side over here by everything on the right side. So if I can take 15,000 divided by all this stuff and get that in my calculator, then I have the initial investment. Well, what I would do, and I found this to be pretty effective for all students, start with the hardest part. Get it out of the way first. So I can go the 0.0675 divided by 52, and that gives me that part right there. Well, I need to add 1 to that. Now I need to take all this answer which I've got in my calculator, and I need to raise it to the 52 times 5 power. So that's my bottom number. It's my denominator. I need to take 15,000 divided by that. That's 10,705.62. Is how much that this person would need to invest right now to have 15,000 cash for a new car in 5 years. Now, we're eventually going to get, this is a little bit, I think, slightly unrealistic because, you know, a lot of people just, if they need to get $15,000 in 5 years, they're probably not going to have a lump sum payment to make that. They may have a lump sum payment, but need to add money per month. Well, that's when it gets fun. Once we get through systems of linear equations and matrices and linear programming, we get into mathematics of finance, and that's when we get into problems like that. So if you had a couple of $1,000s that you could put down, how much would you need to add per month to that to end up with 15,000 after 5 years? So again, those are the fun problems. I don't know about fun, but sort of fun. Certainly real life, certainly applicable to each of our lives. It's like, you know, if you're going to start your retirement account, you know, how many people have $1 million to just go invest in some Roth IRA? You know, it just doesn't work like that for most people. You know, maybe Trump and Oprah and people like that have that kind of stuff going on, but most of us would have to invest doing periodically, you know, so much per month, so much per quarter, so much per year, you know, file it when you file your taxes so you can get a break on that. So guys, we're going to talk about all that, but we need to learn some stuff before we get there. All right, number 5, compute the value of 10,000 invested at 1.35% compounded quarterly after 5 years. Okay, so we need 10,000. Our rate is 0.0135 compounded quarterly. 4 times 5. The only reason I put this on this worksheet because it's exactly like one we did before. I just wanted to see if you can put this in your calculator and get the correct answer. So grab your calculator. I'm going to hang out here for a while and have a drink of coffee and see if you can put this in your calculator and see if your answer matches what I get. Shoot, my coffee's got cold. So let's go ahead and do it. So I'm going to just put this one in all at one time. So gang, I get 10,697.09. You'd only get like $700 interest if this happened over 5 years, but you only get 1.35% compounded quarterly. Now, some of you may not be able to do that. Maybe you got to start with the 0.0135 divided by 4. And then you're going to add 1 to it. Then you're going to raise that to the 20th power. And then you're going to multiply that by 10,000. Same answer exactly. So again, it's just, it's who you are. You know, I get a lot of people ask me, Dr. Darbo, do you think I'm okay to take an online course? I have no idea. I really won't know until the final grades. I don't get to know students on online courses like I do in the classroom. That's one of the things I don't like as much about the online courses. But I think the convenience of students being able to watch lectures anytime, well, practically anytime they want within a week's time, is extremely beneficial. Plus, it's something the university is buying into because we understand that we have to compete with the online universities, online options. So, but if it wasn't pedagogically sound, we wouldn't do it. So I think it is if you are willing to watch the videos and if you're willing to do the assignments and if you're willing to study. But same thing in a classroom. Are you willing to come to class? Are you willing to? So anyway, a lot of similar stuff. All right, number 6. How long would it take money to double if invested at 12.36% compounded annually? Well, guys, didn't we just do something like that in a previous video? Now, this would be a reason that you would want to save your notes. Like those video notebook entries. If you're doing what I ask you and you watch the previous video, all you got to do is go to your notebook and go to the previous page, and you should have written that down because that was a major thing. And what we found is that the time can be found by taking the log of 2 divided by the log of 1 plus r. As long as we have a compounded annually. Now, if this was compounded quarterly, this thing right here ain't going to work. We got to come up with something different. So luckily, we're okay. So guys, what we need here is the log of 2 over the log of 1 plus 0.1236. So the log of 2 divided by the log of 1.1236. So guys, it's going to take about 6 years. Right. 5.9 years. Number 7, I don't know how many problems we got. Hey, this is last page. Cool. Number 7, how many years to 2 decimal places will it take 1,000 to grow to 1,800 if it is compounded quarterly at 6%? So guys, I'll work this one by going 1,800. Starting out at 1,000, compounded quarterly. So 4 times t. Now, gang, we need to clean this up a little bit. So I'm going to do two things. First thing I'm going to do is I'm going to divide both sides by 1,000. So 1,000 or 1,800 divided by 1,000. I mean, I just see that that's 1.8. I think probably a lot of you could too. And along the way, I'm going to go ahead and try to clean this up a little bit. So what is 0.06 divided by 4? 0.015 plus 1. So this part in here I can clean up and make my life a little bit easier by doing 1.015. All right, what happens next? Learn from the past. Log of both sides. What do we do next? Bring that exponent out front. Divide both sides by 4 log 1.015. That 4 cancels. That log of 1.015 cancels. So all I'm left with on the right hand side is t. And over here I have the log of 1.8 divided by 4 times the log of 1.015. So I'm going to do the denominator first. I'm going to take 4 log of 1.015 because I know there could be problems with this, and I'll show you why in just a second. So I need to take then the log of 1.8 divided by the answer, and I'll illustrate why I did this. You guys are going to cock your head a little bit to the right to see that. So it's going to take about 9.9 years. Well, it actually says to 2 decimal places. So it's going to be 9.87 years. For this to happen. Now let me show you why I did some things I did. I've taught this class, I've taught mathematics long enough to know that this is a little tricky in putting this in the calculator if we do it in one operation. And let me show you what a lot of students will do. They'll do that divided by 4 log 1.015. And guess what will happen? They get the wrong answer. The reason they get the wrong answer is order of operations. It's dividing by 4 and then multiplying by, taking log 1.8 divided by 4 and then it multiplies by the log of 1.015. We don't want that. We want the log of 1.8 divided by the quantity 4 times the log of 1.015. And we do that, we get the right answer. But so many students, especially when you're taking a test, you're under stress, you're under time constraints, and it's just a more stressful situation. They'll forget to do stuff like this, and they essentially know what they're doing, but they get an answer that makes absolutely no sense. What happens then? The blood pressure goes up, heart rate goes up, and we start losing our minds. Because we didn't do something as simple as order of operations. So guys, that's the reason I teach that, because I know what happens. So guys, here it's going to take about 9.87 years for this to happen. All right, next thing we get is compounded daily. So I'm going to bring another sheet of paper over here. Compounded daily, we use 360 days for daily compounds. Why, I have no idea. I looked it up one time and I remember finding the answer. It didn't really make a lot of sense to me. Uh, uh, but it's just the way it is. We use 360 for compound daily, even though there's 365 days in a year, at least 3 of every 4. So we want 1800 equals 1000 times 1 plus. We're still at 6%. And we want it to the 360 power times t. So we need to solve for t. It's in the exponent, so we got to have logarithms. That's pretty much the same thing's going to happen. We're going to divide both sides by 1000, giving 1.8 equals, now this 0.06 divided by 360. Let's see if we can get something nice there. And we really don't. We have, it's not like 0.015 like we had before. We have a decimal, infinite decimal of 0.6s. So we're just going to need to let that ride and handle it in our calculator. All right, nevertheless, we're going to take the log of both sides. And we're going to bring the 360t out front. And just as before, we're going to divide both sides by 360 times the log of this. So ultimately, guys, I can put the t is going to be the log of 1.8 divided by the 360 times the log of 1 plus 0.06 over 360. Now, if you're someone that just refuses to get your life organized, I got good friends like that. They just do not like any sort of structure in the way they think. And you know what? Still love them. Still think they're awesome people. But it would drive them absolutely insane for a problem like this. So I'm going to show you the way that someone like that would probably work out well if they can kind of get some forced structure, if you will. I'm going to do the 0.06 divided by 360. I'm going to add 1. I'm going to take the log of that. And I'm going to multiply by 360. All right, guys, hold on just a second. My Mac's getting ready to close down. I need to hook it up to the power quickly. All right, averted disaster. That would have been disastrous if I'd gotten through a 45-minute video and my computer shut down. I lost the video. Well, it would have been disastrous, but I wouldn't have liked it. All right, where are we? We just multiplied by 360, so it looks like to me we've got all of the denominator done. And it's sitting right there. So now I need to take the log of 1.8 and divide it by that number that we worked so hard to get. So guys, 9.80 years. Would be how long it would take. So just a little bit quicker. As the compounds go up, you're going to get more money. So it's going to double a little bit quicker, but only 7/100ths of a year. So don't get all tore up. It's not like it's going to be, let's just see how much it is. It's 7/100ths of a year. And there's technically 365 days in a year. So it's going to, almost a month. It's going to grow to $1,800 in just more quickly, about 25 days. All right, so how many years will it take an investment to double if it is invested 2.95% compounded continuously? So guys, we're going to use this compounded continuously formula. And I want it to double, so for that to happen, my ending balance has to be twice my beginning balance, which is 2p. I'm going to want to divide both sides by p, so I get 2 times ER raised to the t power. Now, since I have base e, I'm forced to use the natural log. You should know by now that we're going to take what's in the exponent, bring it out front. And you should know by now that the natural log of e is just 1. So guys, what we end up with, I'm going to flip these, which is legal. So I'm going to have r times t equals the natural log of 2. And so I've got t equal the natural log of 2 over the rate. Well, guys, in this situation, we want to know that when it takes, how long it takes to double when the rate is 2.95%. So we can quickly see that it's going to be the natural log of 2 over 0.0295. Put that in my calculator real quickly. And I get 23.5 years. That's going to be a long time. That's crazy. In fact, wow. That doesn't even really seem possible. And if I were taking a test, I would check that out. And I would say, okay, let's just choose something. Let's invest $100. And we have E, and we want our rate to be 0.0295, and we got to let our time be X because we can't use T. And I want to go to my window, and again, X is T, so X is the number of years, and this problem is telling me that it's going to be about 23 years, so I'm just going to run this thing out to about 25 years. Y, the only thing has to happen is Y max has to be bigger than Y min. And then we can go zoom fit. So this is our investment of $100, which starts spending exponentially out so far. Well, it's telling me that 23.5 years, so I'm going to go calculate out the value of 23.5 years, and sure enough, that's where it doubles. It gets up to $200 at 23.5 years. So guys, I feel better about it. If this was a test question and I was a student, after testing this, I would feel more comfortable with that being the correct answer. Guys, that's all I got. We will probably end up, this will be the last thing you'll see on exponential functions and logarithmic functions until we have the study guide for the first exam. And of course, you're going to see it come up on the study guide for the final exam too. I'll tell you what I'm going to do. I am going to have a little bit of fun here. I want to see who is actually watching the videos. So Whatever day this is posted, whatever it may be, I am going to give you 5 days to email to me at ddarborough@shawnee.edu. In the subject line, I want you to put quiz number 1. So that's going to go in the, I don't even know what we call that. Let me take a look here. If I'm going to create I just call it the subject line, but who knows? It's going to be, yeah, subject. Okay, wow. You guys are probably thinking I'm insane. So subject quiz number 1. And I'll tell you what I want to do. I want to play a song for you guys. Well, my iPhone's not working. Huh, that's weird. Well, my iPhone is just died. I was going to play a song for you that I find to be one of the most annoying songs I've ever heard. It's by Taylor Swift. Taylor Swift's fine. Don't be, Taylor, if you're out there watching my math videos, don't be flipping out on me. But yeah, I don't know. I was going to play it, but anyway. So this is kind of an annoying song quiz. So if you type this, the most annoying song I've ever heard is, then I will give you 25 points, not extra credit. 25 points out of 25 points for quiz number 1. So you got to do it by 5 days. So for example, if this video is posted on December the 10th, and it's not going to be, but if it's posted on well, it could be, I don't know, December the 10th, then all the students who get this to me by midnight on December the 15th, 5 days later, you're going to get 25 out of 25 points. I'll tell you, for the most part, I just want to see who's watching the videos in a timely manner. I'll tell you what I'm going to do. I'm going to give you 6 days. So 6 days later, because that's almost a week, so you should be watching these videos within a week. If not, you and I need to talk. Or, sometimes things come up, but for the most part, week in, week out, we need to talk. So, guys, if you'll do that, whatever day this is posted, I know I'm putting this up today, it's going to be posted tomorrow, but I don't want to mention the date because I may want to use this video in future semesters. But whatever day this video is posted, 6 days later, by midnight, if you send me an email, subject line quiz number 1, the most annoying song I've ever heard is, I'll probably go listen to it just to see if we agree. You'll get 25 points out of 25 points. Guys, have a great week, end of your week, or a great end of your day, or whatever's going on. And get those assignments turned in on time. Some of you have been slacking just a little bit on that. Overall, the class is doing well, but there have been a few people that need to step it up a little bit. So, guys, have a good one.